Okay, today we're going to cover nested for loops, and what we're going to do is we're going to write a little program using a four-step program. This four-step program is to understand, plan, implement, and then reflect. We won't do a heck of a lot of reflection in this lesson, though. That is an important step. Then, as we do this, we're going to write our nested for loops in two different ways. One is mathematically, and the other one, I don't really know what to call it, so I call it cumulatively. Two different ways to think about the programming mechanism, or ways to program, so we're going to do them both. All right, so first thing is you're going to write, or no, you're gonna determine what this program outputs. So I want you to look at these two for loops, and then the output, and then the print line, and I want you to determine what this will print. So it's important, since you're watching a video, that you learn how to hit that pause button. It's going to help you out. So I also found that if you create a table with something like this, that it can help you determine what this outputs. Okay, I'm going to pause. So you're going to pause. And when you figure it out, let me know. Oh, already. Okay, here we go. All right, so this is the output here on the left. 13579, 1357, 13, and then 1. So how do we do this? Well, the one thing we can do is we can start to just look at this outer loop here. So if you look at this outer loop, we're going to start at 11, and then we're going to subtract 3 every single time, and we're going to do this while foo is greater than -9. So if we start at 11, subtract 3, that'll get us to 8. Subtract 3, it'll go to 5. Subtract 3, it'll go to 2. Subtract 3, go to -1, right? And then we would go further, right? We would go down to -4 and so on. But let's see what happens when we come up here. So when I use bar is going to start at 1, and then it's going to go to as long as it's less than foo. So bar is going to start at 1, and it's going to go, counting up by 2, as we see on here. It's going to go from 1, 3, 5, 7, 9, and it'll keep going by 2 as long as bar is less than foo. So I can't go to 11 because 11 is not less than 11. So when I go into my next loop, where foo is 8, that means I'm going to go from 1 to less than 8, stepping by 2. So 1, 3, 5, 7, I have to go less than 8. The next loop, 1, 3, I'd go up to 5, but 5 is not less than 5, so I stop. Okay, now here I'm going to start at 1, and I would go to 3, right? But 3 is not less than 2, so then I only print 1. Then I would go again, right? This outer loop is going to keep going, right? It's going to go to -1, it's going to go to -4, and it's going to go to -7. But notice that when I get to -1, I'm going to start at 1, and while 1 is less than -1, is 1 less than, while 1 is less, 1 is not less than -1. So it's going to skip this loop, and it's going to skip this loop, and it's going to skip the loop. So there are empty print lines at the bottom of this. So that's how we would step through a nested for loop. I find that using a table like this can be very helpful, and looking at the outer loop first, holding that foo value constant, or that outer value constant, and then looping on the inner side. All right, again, we're going to have you pause. What will this do? All right, coming back. Hopefully you paused and you figure out what this is going to do. So let me give you a tip here. Let's look at these i's, and let's replace the I with number. And we're going to place j with, where's j? Just this one j. Do we have a j is never a reference, so I'm going to replace that with something else. So here's that code, the very same code we've written. It looks the same. Okay, wait, you're saying it's not the same. Well, we've got i's and j's. And it looks a little fuzzy too. I's and j's are here. So I got I in the outer loop. I is less than 3, I plus plus. And then j is equal to 0. I is less than 3, I plus plus. So you could see that if I just replace all the i's with nums, this is the very same loop. So now, what does this print? It's very tricky, right? What's going on here? Can you have an inner loop using the same variables that you would in the outer loop? Of course you can. It's confusing, it's weird, it does some strange stuff. What happens here? Well, the answer is what? 3 times, and you have to have that. The last one has a higher pitch to it. What? It only goes 3 times. So if we did a variable table, which apparently I don't have, what you would see is that num is equal to 0, and I start off in my initialization. While num is less than 3, I'm going to come in here. So unused is equal to 0. All right, well, I don't care because unused is, well, unused. Now num is equal to 0. Is num less than 3? Yes, it is. So I increment it by 1. And then I increment it by 1 again, and I increment it by 1 again, and that's what I'm going to print. On what? So num becomes 3, right? Num is 3 on my inner loop. When I exit my inner loop, I go up to my updater out here. Num becomes then 4. Is num less than 3? It is not. It exits. So I execute the outer loop only once. I execute the inner loop 3 times, and I print what 3 times. Takeaway from here, don't use i's and j's. They are so confusing. Like when I look at this, this back here, it just hurts my eyes, you know, and it's fuzzy. I's and j's are horrible when they hide bugs like this, especially when you do copy and paste. And so it's better if you can use like numbers or inner or full names for the identifiers up here, like num or number or index or something else like that. And it'll really help you spot the problems in your code. So let's go on. We're now going to go to our coding exercise. What we're going to do is nested for loops, and what we're going to do is we're going to output these 6 lines together. Okay, do you see how we have these x's and zeros? These are zeros. X's and zeros. X and O's. I don't know. I don't feel like hugs and kisses today. So we're going to go with x's and zeros. We're going to be football. Okay, so I don't know. Football uses x's and zeros, but there we go. We want to output this. How can we do it? First thing we need to do is we need to understand what we're doing. To do that, often we create a table. I know most of you students are thinking, why do I have to create a table? I can juggle it all in my head because I'm brilliant. And you know what? On the AP exam, if you can juggle it all in your head without writing anything down, you get extra credit. No, you don't. You don't get any extra credit for juggling in your head. If you write it down and you make it simple, you get the right answer, then you get points. If you juggle it in your head, you don't, and then you get it wrong or you get confused, you don't get any points at all. So here we have just an explicit way of showing what we're trying to draw. On our first row, we're trying to draw 5 x's and then no o's. Okay, zeros. Then we're going to on our second row, we're going to do 4 x's and 1 0, and then we're going to do 3 x's, 2, 1, right? These are the number of x's we draw, right? So if I go back to here, you can see I'm just counting up the number of x's per row. So when I do this and I go, okay, that's what I'm going to do. I have my rows, I have my x's, I have my zeros. That's what I'm doing. Okay, what's my next step? First step was to understand. I think I understand, Mr. Stride. Please move on. We're going to plan. We're going to make a plan. So what we're going to do is I'm going to use this mechanism called, I know you may have never heard of this thing, it's called math. So if I look at these, I can think of this as my x-axis, and I can think of this as my y-axis. So I can think of a point, 1, 5, 2, 4, right? I could have done 3, 3, but I got a point. See, my x and my y, okay, represents these numbers here. So I have these points. So what I'm going to do is I'm going to think about this like a math problem. I'm going to find the equation that goes through these 2 points. So let me find the slope, right? I take 4 minus 5, my rise, and divide by 2 minus 1, my run. That gives me -1. That's my slope. That's my n, and y equals mx plus b. So that means my x here, right, that was like my y. So y here is equal to my slope, which is -1, times my x, which is rho. This is weird. We're using different variables. It's substitution. You're going to have to wrap your head around it. Y is equal to mx plus b. The count of x's is equal to -1 times my rho plus b. So now let's solve for b by substitution. We're going to put in a point. I just put in this point, 1, 5, in for my x's, right, and my rho. And then I solve for b. And then when I solve for b, I get b is equal to 6. So then my equation is the count of x's is equal to minus rho plus 6. And I'm going to simplify that to make it look a little bit better. My count of x's is equal to 6 minus rho. All right, let me reflect on that a little bit. Does that make sense? Is my count of x's equal to 6 minus rho? 6 minus 1 is 5. Oh, 6 minus 5 is 1. Oh, 6 minus 6 is 0. Oh man, that's pretty simple. I should have been able to see that. Well, I did the math because not everything is so simple. But if you think of it as these are just 2 points in a plane, and you can use the algebra or the geometry that you've learned in other classes, you can find the equation to count the number of x's. We would do the same thing for the number of zeros, all right? So I got my row here, and then my count is 0. So I got my point 1, 0, right? 1, 0. I'm going to go just to the second one. I could use any point on here. It would still work. I go 2 and 1, 2 and 1. So I'm going to use my math, okay? This is my method number 1 still. Slope through the points, do my rise over 1. I get 1. That means my count of zeros is 1 times rho plus b. So by substitution, I add the point back in. And what I get is simply that b is equal to minus 1. So I plug that in my equation, my y equals mx plus b, and I get the count of zeros equal to rho minus 1. Let me reflect to make sure that's correct. Rho is 1. If I subtract 1, I get 0. Well, that looks right. So let me look at this. Rho is 4. If I subtract 1, I get 3. Oh yeah, that worked. My rho is 6. If I subtract 1, I get 5. Oh, okay, so this equation appears to work, right? Now, I can look back at what I have. This is what I want to draw, right? And so I'm still making my plan, and I go, this is my count of x's, and this is my count of zeros. And I look at that and I go, all right. So now I need to do some pseudocode. I'm going to do 6 rows, and then for each row, I'm going to print some x's, and then maybe some o's. Or I'm going to print maybe some x's and then some o's, right? How many? Well, 6 minus rho and rho minus 1. So here's my pseudocode. I'm going to, for each of the 6 rows that I have, I'm going to print this many number of x's, and I'm going to print this many number of zeros. I keep saying o's and zeros. Oh, so confusing. And then I'll do a new line, right? After I do one little x here, and then I do the o's. So notice here my very first row is 1, row is 1, 1 minus 1 is 0, so I'm going to do 0 zeros, which is exactly what I have up here. So that's how I want to print. That's my pseudocode. This is kind of like English. Now I have my plan. Third step is to implement. First step was to understand. Second step was to make a plan. See, a lot of math happened there. I have some pseudocode in here. I got my plan. Converting this into actual code is not that hard. Let me reload. Please don't go away. What happened to my... I don't know what happened there. Parts of the slide didn't load. Try reloading. Okay. That is so crazy. Here it is. All right, computers. Gotta hate them. So here's my third step. Implement. So I would take my pseudocode, which is for each of the 6 rows. Let me convert that to actual code. For loop. Int row. Notice I don't use I. 1. While row is less than or equal to 6, row plus plus. I know that this is going to go 6 times. It's a very convenient looking, very repetitive looking for loop. Okay, it's a canonical form. Row equals 1, less than or equal to 6, row plus plus. This will go 6 times. I want to print 6 minus row x's. X is 1. X is less than the count that I want to do, x plus plus. It looks very similar to the rows above there, except now that I have 6 minus row. That will do 6 minus row x's, and I print that x, not print line, I do a print. I want to print row minus 1 zeros. So I do my for loop. Zeros is equal to 1. Zeros is less than or equal to what? My count. What is my count? Row minus 1. Row minus 1. Zeros plus plus. I print my zeros, and when I'm done, I just print a blank line to go to the next line. And this is the code you would use. Okay? This is how you would print out the boxes that I've shown before. Is this going to show up now? Oh, so lame. We're going to do this again. I'm going to do it a different way. Let's say that way didn't make any sense to you. Mr. Stride, that was so confusing. I hate math. Math, yuck. So what we do is first we got to understand, hey, same step, same table, same idea. But instead of this time, I'm going to use a cumulative count method, which may be somewhat intuitive. So the first thing I'm going to do is I'm going to see the x's start at 5, and then they go down 1 each time. So my delta, or my change, is -1. Do you see how much I change by -1 every single time? I just go down by 1 every single time. I start at 5 and I go down by 1. Oh, okay, that's pretty clear. My, oh, it's not count of y's. Count of zeros, okay? Count of zeros starts at 0 and goes up by 1. 1, 2, 3, 4, 5. Yes, Mr. Stride, I can count down, I can count up. So simple. So let's do some pseudocode. My count of x's start at 5. My count of zeros start at 0. For every single row, I'm going to print the x's that I have. I'm going to print the zeros that I'm supposed, the count of zeros, right? Then I'm going to decrease my count of x by 1, because every single time I go down by 1. What will I do next? Duh! I'm going to increase the count of zeros by 1, because every time I go through my row, I increase by 1. And then, of course, I do my blank line at the end. So I just start at my top value, For each row, I print my x's, print my o's, and then I decrease the count of x's by 1, and I increase the count of zeros by 1. Why, what could be simpler? That slide didn't load. So let's look at the code here. I'm just going to take that same pseudocode, start out at the right values. I'm going to add some code. So int count of x is 5, int count of zeros is 0. For each row, look, my outer for loop is the same. Row equals 1, row is less than or equal to 6, row plus plus. That's my canonical way, it's my standard way, it's my very common way that everyone understands how you do a loop 6 times. Then I print my x's. How many? Count of x. See, I just stuff count of x in here. That's how many x's I'm going to print. How many? The count of x many. I'm going to print that many. Then I go to print zeros. How many? The count of zeros many. I start at 1, less than or equal to count of zeros. I do that many. Then I print the 0. Then each time I go through my loop, I just said I change. So I'm going to use my increment operator and my decrement operator here, not necessarily in that order. These are my unary operators, minus minus and plus plus. Decrement, increment. Then I print the next line. Whew, that's cool. That's how that works. Okay, so we were able to print that up, and that doesn't work. Oh, that's the end. So now you've done a nested for loop review in 2 different ways, okay? Using some steps. First step was to understand. You have to understand what you're doing. If you don't understand it, you can't code it. Second step is to make a plan. You have to make a plan. That often includes pseudocode. Make sure you know it can work. Make sure you can describe it to your grandmother, even yet, to my dad. If you can't describe how you're going to solve it to my dad, you ain't going to be able to do it in code. If you can't describe it in English, you can't do it in code. Third, you implement, and then when you're done, you should look back at it. Oh, let's look back. I like that. That's a good reflection. Okay, we are done.